Hello guys, welcome all. This is Dr. Abhinav Goyal, and in today's lecture we will discuss measures of central tendency. This is the part of quantitative techniques for management for the MBA student, and this is also helpful in BTech courses, in BCA and BTech and BSc and so on. So the first question arises, what is measures of central tendency? So in the statistics, a central tendency or a measure of central tendency is a central or a typical value for a probability distribution. When we are trying to find the solution of a probability distribution, then the central value or a typical value that arises is known as the measures of central tendency. Means uh, the tendency to approach the central value is known as the measures of central tendency. Generally, we know that it is as a average. According to Professor Bowley, averages are statistical constants which enable us to comprehend in a single effort the significance of the whole. Means by the statistical constraints we can comprise the entire data by an efforts in the form of average. So it is the representative of the entire distribution. The following are the 5 measures of central tendency. First one is arithmetic mean. Second one is geometric mean. Third one harmonic mean. Fourth median, and fifth is the mode. So in this particular lecture we will discuss only about all these fives. So requisites for an ideal measures of central tendency. So according to Professor Yule, the following are the characteristics to be satisfied by an ideal measures of central tendency. So what are the prerequisites to measure say central tendency? First, it should be rigidly defined. So the data which are given, which should be defined. It should be readily, comprehensively and easy to calculate. It should be based on all the observations. It should be based on all the observations which are given or arises to after observing a data. It should be suitable for further mathematical treatments. It should be affected as little as possible by fluctuations of sampling. If we change some data or we add or subtract some data, so by this the data will fluctuate. So by the fluctuation of the data, the impact should be minimum. So importance of measures of central tendency. To find representative values, the measures of central tendency or averages give us one value for the distribution, and this value represents the entire distribution. In this way, averages convert a group of figure into one value. Say we have a data of heights of some students. Suppose 160 centimeter, 162 centimeter, 165 centimeter, 180 centimeter, 172 centimeter, 175 centimeter, and so on. And we can say the average of height of these students is around 6.9 169 centimeter. Then this 169 is representing the entire distribution or the entire data, right? So this is, we can say this is the average which represents the entire given data. To condense data, collecting and classified figures are vast. To condense these figures, we use average. Average converts the whole set of figures into just one figure and thus helps in condensation. To make comparisons, to make comparisons of two or more than two distributions, we have to find the representative values of this distribution. These representative values are found with the help of measures of the central tendency, and it helps in further statistical analysis. So if there is some data is given and we analysis by the formulas and we get the average of the value, then this analysis or this find value will help in further analysis. So the arithmetic mean, what is this? This is simply the mean or average, and we can find this only when the context is clear and by the rule the sum of all the data divided by the number of collections or number of objects or number of articles. Means arithmetical mean is defined by dividing the sum of collection of numbers by total number of collections. The collection is often a set of results of an experiment or an observational study, or frequently a set of results from a survey. Just like I discussed an example in the previous slide of the height of the student. In addition to mathematics and statistics, the arithmetical mean is used frequently in many diverse fields such as economics, anthropology, history, in optimization, or we can say it is used in almost all the academic fields in some context, whether it is in a minor state or in a major state. For example, per capita income is the arithmetic average income of a nation's population. Or if we have to find per capita income of a colony or per household income of a colony, then we can use this arithmetic mean concept. So mean is of two type. Mean is of two type because there is a data of two type. One is grouped data and another one is ungrouped data. So first we will discuss the ungrouped data. So ungrouped data is where the frequency is not given. So to find the mean for this kind of data, the arithmetic mean or average, it is generally represented by x bar. So if we have to find the mean of the n values x1, x2, x3, x4 up to xn, then this x bar is the 1 upon n summation of I equals to 1 to n xi. This summation I equals to 1 to n means xi means we have to expand this xi up to the n for the value 1 to n in this particular manner. x1 plus x2 plus up to xn upon n. It means the formula which we discussed earlier, which is representing in the numeric form, that is sum of all the observations. This x1 plus x2 plus x3 up to xn represents the sum of all the observations, and this n is represents the number of observations because we are taking n values. N values means n observations, and observations are x1, x2, x3 up to xn. So sum of all the observations upon number of observations. For example, if we consider the monthly salary of 5 employees of a firm, 2500, 2700, 2400, 2300 and 2000. This is the example of very earlier time when the value of 1 rupee was very high. So if we want to find the average income of these 5 employees, then how to get sum of all the observations upon number of observations? So number of observations are 5. So right there. Sum of all observations, that is this sigma xi, 2500, 2700. Okay, I write this wrong. This 0 must not be there. So 2500 plus 2700 plus 2400 plus 2300 plus 2000. So what is the sum? Add them. 2500 plus 2700 is 5200. 5200 plus 2400, 7600. 76 and 2300, 9900. And 2000 means how much? 11,900. And it is divided by 5. So what will come? Divide this 11,900 by 5. It will be 2,300 80. So this is the average income of these 5 employees of a firm. So hope you understand this particular example. In this manner, we can calculate any kind of data, average of any kind of data, only in the case when the data is scattered, that is the ungrouped data. And when there is the frequency distribution is given, then frequency distribution means Fi. Then we can convert this formula as 1 upon n summation I equals to 1 to n xi fi. So n, basically n represents the summation of frequencies, that is the sum of all the frequencies. Suppose there is a data, this represents the x and this is f, and we have to find the xf. So this xf, from where it comes? When we multiply the corresponding x to f, then we can get the corresponding xf. Xf means when this is written xi fi means when we put I equals to 1, then x1 f1. So x1 f1 will be representing in the first value for the first tabulated value, x2 f2 will be for the second tabulated value, x3 f3 for the third tabulated value, and so on. So now moving on to the mean for grouped data. So there are 3 methods to find the mean of the grouped data. The one is direct method, second one is shortcut method, and the third one is step deviation method, or the simply deviation method. So in the direct method, the formula which was taken in the previous slide is representing the direct method. So here xi is taken as the midpoint of the corresponding class, right? In the shortcut method, we convert this formula as x bar is equals to a plus 1 upon n sigma I equals to 1 to n di fi, where A is any arbitrary point, or we can say this is a assumed mean. We have to assume a data or a number from the given x and we let it as a, and when we subtract this a from all the data given, that is all the x, then we find the d. D is deviation. So di is equals to xi minus a. And the step deviation method, it is used only when the data is very large. So in that case, data is very large and the class interval, and there is a uniform class interval. Then we can write this as a plus h upon n, this formula, where di represents the xi minus a upon h. H represents the class widths, or we can say h is the common magnitude of the class interval. Weighted mean. Weighted mean is the mean of the set of values wherein each value has a different weight or degree of importance. Let Wi be the weight attached to the items xi, then x bar will be sigma I equals to 1 to n Wi xi upon sigma I equals to 1 to n Wi. This Wi, if we replace this Wi by the fi, then it will be the formula of the mean when data is in the group and frequency is given. So this is as same as the previous formula. So in case of weighted mean, there are following three cases arises. Number one, if weighted mean is equals to simple mean, then the weight associated to each value is equal. If weighted mean is greater than simple mean, the large weights are associated or assigned to large values, or we can say the smaller weights are assigned to the smaller values, and vice versa. If weighted mean is less than simple mean, the large weights are assigned to smaller values and vice versa. Merits of arithmetic mean. So what are the merits to find the arithmetic mean? The very first merit is it is rigidly defined. So when we find the arithmetic mean, then it is purely defined term. It is easy to understand and calculate. Yes, it is very easy to understand and very easy to calculate. It is based upon all the observations. It is suitable for further mathematical treatments, and it is least affected by the fluctuation of sampling. It is already discussed in the previous slides. And now come to the demerits of the arithmetic mean. So there are so many demerits. Some are, it cannot be determined by inspection, nor it can be located graphically. So by the inspection, only seeing the values, we cannot determine the mean, or we cannot locate it on the graph paper. By seeing a graph, we cannot determine the mean of the given data. For the finding the mean, we have to calculate it by as per the given formulas and given data. It cannot be used in case we are dealing with qualitative characteristics. If there are a data which contains only qualities, not the quantities, then we cannot use any formula to determine the arithmetic mean. Now we see this product is very good, this product is bad, that product is good. So by this qualitative characteristics, or some of the part of this product is very fine, some are the average. So by these data, we cannot find the arithmetic mean. That is, we cannot make any decision based on these type of data. If a single observation is missing, then we cannot calculate mean unless the missing observation is dropped out. Yes. If there is any data is missing corresponding to any of the value, then we cannot calculate mean, because what should we put in place of that particular value. So we can calculate mean only when we drop the missing observation, or we put a hypothetical value in place of that missing observation. So arithmetic mean is affected very much by the extreme values. It cannot be calculated if extreme class is open. Yes. In skewed distribution, mean is not a suitable measure of location. If data is skewed, then we cannot locate the exact value by the mean. When to use mean? So in a skewed distribution, the mean can miss the mark. In the graph above, it is starting to fall outside the central area. This is falling basically. This problem occurs because outliers have a substantial impact on the mean. Extreme values in an extended tail pull the mean away from the center. These. So what will happen? This mean will be shifted from the center to this extreme inside of the extreme values. As the distribution becomes more skewed, the mean is drawn further away from the center. If we stretch the data so far, then this mean will also stretch or go beyond the mid value. The mean is drawn further away from the center. Consequently, it is best to use the mean as a measure of the central tendency when you have a symmetric distribution. So we can find mean only in terms of a symmetric distribution. So guys, moving on to the question based on the ungrouped data. So the height of 10 children is given as 120 centimeter, 124 centimeter, 125 centimeter, 121 centimeter, 119 centimeter, 130 centimeter, 121 centimeter, 123 centimeter, 129 centimeter and 132 centimeter. Find the mean height of these children. We have to find the mean height of these children. So first we have to identify which kind of data is given. Data is not in the form of a table. So this is ungrouped data or the scattered data. So in that case we can find the mean for the ungrouped data is x bar is equals to sigma I equals to 1 to n xi upon capital N. That is sum of all observations upon number of observations. So it is equals to 120 plus 124 plus 125 plus 121 plus 119 plus 130 plus 121 plus 123 plus 129 plus 132 upon number of observations are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the 10 numbers are the observations. So add all these data. After adding, we get 1244 and divide by 10. So it is 124.4 centimeter. So the answer arises, the mean height of these children is 124.4 centimeter. So this solution or this number is representing throughout all the data. Hope you understand this particular question based on the ungrouped data. This is for you. The weight of 8 students of a class is 45 kg, 46.3 kg, 47.8 kg, 52 kg, 54 kg, 58 kg, 69 kg and 41 kg. Find the average weight of the class. You have to solve this particular problem. So now moving on to the next problem. The distribution of height of 50 students was as under: height and the number of students 110, 6, 115, 8. This is in centimeter, height in centimeter. So 110 height of the 6 student, 115 for 8, 118 for 14, 120 for 15, 121 for 4 and 125 for 3. So we have to calculate the mean height for this distribution correct to one place of decimal. So in this particular case, height and number of student is given. Number of student is representing the frequency f and this height is for the x. So there is frequency is given. So the data is a grouped data. So in that case, we first have to find sigma xi fi. So for this, we make a table. So to solve this, we have to find the xf. Xf means we have to multiply this x to the corresponding f. 110 multiplied by 6 is equals to 660. 115 multiplied by 8, 920. 118 into 14. So in this manner, when we multiply, we get these data. And so from there, this is sigma xi fi or simply xf. This is equals to, it is around 5891 calculated once. And this sigma f, no need to add these. This is given that this is the data of 50 students. So this sigma f is the 50. So here sigma I equals to 1 to n. Xi fi is 5891 and sigma fi or simply capital N is equals to 50. So mean x bar is equals to 1 upon n sigma I equals to 1 to n xi fi or 5891 upon 50. So divide the data. 5891 divided by 50. 117.82 centimeter. So mean height of 50 students is 117.82 centimeter. So this is the answer. Now coming to next question, find the mean of the following frequency distribution by direct method, shortcut method and step deviation method. The data is marks given 0 to 8, 8 to 16, 16 to 24, 24 to 32, 32 to 40, 40 to 48. Say this is the data from the 50 marks. So the number of students getting these type of marks are 5, 3, 10, 16, 4 and 2. So we have to calculate mean marks with the help of the three methods: direct method, shortcut method and the step deviation method. So first, applying the direct method. So in case of the direct method, as solved in the previous question, we solve this. So there is frequency distribution is given, that is the marks. These are in the class interval, so first we have to convert them in the form of x. And it is number of student representing the frequency 0 to 8, 8 to 16, 16 to 24, 24 to 32, 32 to 40 and 40 to 48. And this is 5, 3, 10, 16, 4 and 2. So in the direct method, we have to find the x by adding lower limit and upper limit and divide by 2. So the average of the lower limit and upper limit is the value of x. So 0 plus 8 divided by 2 is 4, 8 plus 16 divided by 2 12, 16 24 is 20. Now you can make a symmetry, 4 and 8 12, 12 8 20. So next will be 28, next 36 and next will be 44. So this is the data, x is given, f is given. So in the direct method you have to find the xf. How to get? Multiply these, 4 5 is 20, 12 3 is 36, 20 10 is 200, 28 16, 448, 36 4 is 144, 44 2 is 88. So find sigma xf and sigma f. Sigma f will be, add these, sigma xf 936. So mean equals to sigma xi fi, I equals to 1 to n upon capital N. So it is 936 upon 40. So it will be 23.4. These are the mean marks. So this is by the direct method. Now applying the shortcut method. So in shortcut method, we require these data as it is. So we copied this from the previous step. Now in this particular data we required A. A is assumed mean. How to get the assumed mean? From the x we mark a point as A which is from the data given, or you can take outside from the data, that is we can take A as a middle value. So there are 6 data, so either take 20 or 28. If you are choosing from the given data, either you can take the average of these two data, that is the 24 as a assumed mean. So I am taking this 28 as a assumed mean. So from this you have to find D, which is equals to x minus a. How to get? Subtract all these data, subtract this 28 from all these data. So 4 minus 28 minus 24, 12 minus 28 minus 16, 20 minus 28 minus 8. This is 0, 8 and 16. Now find FD. So you have to multiply this and this. So how to get 5 into minus 24? So it will be 120 minus 48 minus 80. This will be 0. This 32 and this also 32. So sigma FD will be, add all these data, some are negative, some are positive. So the sum is minus 184. So here A is equals to 28, sigma F is equals to 40 or N, and sigma Fi Di is equals to minus 184. So mean x bar is equals to A plus sigma FD upon sigma F. So 28 plus minus 184 upon 40, or 28 minus 184 divided by 40, 4.6. So it will be 23.4. So the result is same as the previous method. The only difference is the data is smaller than the previous data. So now in this method, this data is already given because we require this much of data. In this particular step deviation method, we require, since this x is very high, and when we divide this x by a, then the data present is very high. So we can summarize or we can change the data in the smaller way of by getting h. What is the h? H is the difference between these two or the difference between these two terms. So the H is 8. So we can get D as, in this particular method, x minus a upon h. So x minus a, that is 4 minus 28 is minus 24 divided by 8. So it is minus 3. 12 minus 28 minus 16 divided by 8 minus 2. 20 minus 28 minus 8 divided by 8 minus 1. This is 0. Similarly, this is 1 and this will be 2. Right? Now the d is very small. So you can easily calculate FD minus 15 minus 6 minus 10 0 4 2 2 ja 4. So this is minus 15 minus 6 minus 21 10 minus 31 plus 8 minus 31 plus 8, that is I think minus 23. So here h is 8, a is 28, sigma f is 40 and this is minus 23. So mean is a plus h sigma fd upon sigma f. These formula can be written as simple by removing I. So a is 28 plus 8 into minus 23 upon 40, or 28 plus 8 into 8 5 is 40. So it will be, when we divide this by 5, minus 4.6, so it will also equals to 23.4. So the solution from each method is same. So you can opt either of the method to get the mean for the grouped data. Hope you understand the entire phenomena. Now come to the geometric mean. The geometric mean of a set of n observations is formally defined as the nth root of their product. If there are small n observations, then its geometrical mean will be its nth root of the product. If we have x1, x2, x3, x4 as the data, then the geometric mean will be fourth root of x1 into x2 into x3 and into x4. So how to calculate? Calculation of geometric mean. From the definition, the geometric mean G. G or Gm. We can represent it by the G or Gm. Of n observations, xi is given by G is equals to x1, x2, x3 up to xn power 1 by 2. The square root of product of all the observations. So if we use the log and compute, finally we can get log G equals to 1 upon n sigma fi xi. Thus we find that logarithm of geometric mean is the arithmetic mean of the logarithm of the given values. In case of grouped or continuous frequency distribution, x is taken to be the value corresponding to the midpoint of the class intervals. So geometric mean of the combined group, if n1 and n2 are the sizes g1 and g2, the geometric mean of two series respectively, then geometric mean G of the combined series is given by log G is equals to n1 log g1 plus n2 log g2 divided by n1 plus n2. In general, if g1, g2 up to gk are the geometric mean of k groups having n1, n2 up to nk, observation respectively. The geometric mean G of the combined group consisting of n1 plus n2 plus n3 up to nk observations, which can be written as G equals to antilog, because we are finding the geometric mean. So by removing this log, we have to take the antilog. So when we take antilog, then antilog into log will be cancelled out. So G will remains, and here there is no log, so antilog will arises. So antilog of n1 log g1 plus n2 log g2 up to nk log gk divided by n1 plus n2 plus n3 up to nk. So what are the merits and demerits of the geometric mean? Merits of the geometric means are, it is rigidly defined also, as the mean is defined. It is based upon all observation. Yes. If any observation is missing, then we cannot calculate it. It is suitable for further mathematical treatment. Yes. It is not affected much by fluctuation of sampling. This is also as same as the arithmetical mean. It gives comparatively more weight to small items. What are the demerits? Because of its abstract mathematical character, geometric mean is not easy to understand and calculate for a non-mathematical person. Yes. If anyone is not from the mathematical background, then it is not easy for him to calculate the geometric mean, because it consists of a lot of mathematics. So if any of the observation is 0, then the product of all observation will be 0, and if the product of all observation is 0, then the geometric mean will also become 0, and if any one of the observation is negative, then the nth root of the geometric mean will become imaginary. So regardless of the magnitude of the other items. So where to use the geometric mean? We can use geometric means to find the rate of population growth and the rate of interest in the construction of index numbers. So come to the median. The median is the value separating the higher half from the lower half of a data sample. A population or a probability distribution. Data may be in the form of population or a probability distribution. For a data set, it may be thought of as the middle value. For example, in the data set 1, 3, 3, 6, 7, 8, 9, these are the different data, and from these data the median is 6. How to get? We have to select the value which is arises just in the middle, which is the median. Whether it is a greater value or a lesser value, uh, it doesn't matter. So this 6 arises in the middle, because before this 6 there are 3 values, and after 6 there are also 3 values. So 6 is the median. So in the first 4 data, this is the largest value, and in the last 4 data, this is the smallest value from the given sample. So how to calculate the median? There are two types of data. One is discrete data and another one is group data. Discrete means ungroup data. So first arrange the data in the ascending order and then calculate median by the formula n plus 1 by 2 term. N plus 1 by 2 term when the n is even. Now this formula is for the when the n is odd. we have to replace the places of these two. So we have to find median by the formula n plus 1 by 2th term if the is the median if n is odd, and if n is even then we have to find the average of n by 2th term and n by 2 plus 1th term. On this we will take some example. For group data, median is equals to L plus H n by 2 minus f upon Fm, where small l is the lower boundary of median class, capital N is the total number of frequencies, small f is cumulative frequency of class preceding median class, small h is class width of the median class, and Fm is the frequency of median class. So this formula will also be discussed in an example in case of the group data. So what are the merits of the median? This is also rigidly defined as in the case of mean. It can also be used for the quantities. Those cannot give an arithmetical mean as in the case of intelligence, etc. It is possible to arrange in any order and to locate the middle value. For such cases, it is the best measure. It can be located graphically. Even if the value of extreme item is much different from other values, it is not much affected by these values. Extreme items may not be available to get median. Only if numbers of term is known, we can get the median. If the number of terms is unknown, then we cannot get the median. What are the demerits? Even if the value of extreme item is too large, it does not affect too much. But due to this reason, sometimes median does not remain the representative of the series. Say we have a data 1, 2, 2, 3, and after that 99, 100, 103. So in this particular data, 3 is the median. But we cannot say 3 represents the whole the data, because this starting data is very low and the last data is very large. So in this type of data, we cannot calculate median rightly. So median cannot be used for further algebraic treatment. Unlike mean, we can neither find total of terms as in case of arithmetic mean, nor median of some groups when combined. Yes. In a continuous series, it has to be interpolated. We can find its true value only if the frequencies are uniformly. If the frequencies are uniformly spread over the whole class interval in which median lies. It is affected much more by fluctuations of sampling than arithmetical mean. Next question is, the wicket taken by a team in 9 cricket matches are as follows: 2, 6, 4, 5, 0, 3, 8, 7, 9. Find median of the data. So this is the ungrouped data. So for finding the median, we have to arrange the data in the ascending order. Arranging data in ascending order. So the smallest number is 0, then 2, 3, 4, 5, 6, 7, 8 and 9. So data is, number of term is 9, 9 is odd. So median is equals to n plus 1 by 2th term. As discussed, so n is 9 plus 1 by 2th term. So it is equals to 10 by 2th term. So it is equals to 5th term. So what is the 5th term? This 5. So 5 is the median data. That is, from this we can say a team can take 5 wickets in a match. Whereas if there is a data of 10 cricket matches, so one will be there. Now this data is converted into the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now in this particular case, n is equals to 10. So median will be n, 10 is even. Average of nth term plus nth by 2 term plus n by 2 plus 1th term. So it is equals to 10 by 2th term plus 10 by 2 plus 1th term. So it is equals to 1 by 2 of 5th term plus 6th term. So in this particular case, 5th term is 1, 2, 3, 4, 5 and 6th term is 5. So 4 plus 5, that is 9 by 2, that is 4.5. So a team can take on an average 4 to 5 wickets in a match. So the next question arises, find the median marks of the student from following data. Marks of 10, 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. Number of the students 8, 10, 20 to 40 and 20. So this is the grouped data, and for this group data, and we are finding the median for this. So first we have to calculate the cumulative frequency. CF. So how to get the cumulative frequency? This can be this starting is the same, and next will be getting from the adding of the succeeding to the previous one, that is 8 plus 10, that is 18, 18 plus 22, 40, 40 plus 40, that is 80, and 80 plus 20, it is 100. Here you have to calculate the n. The sum of all these observation is 100. So the sum and the last cumulative frequency should be same. If they are not same, then you made a mistake. Now the n is 100, which is the even. So in this particular case, we have to find the n by 2, that is the 50. At which place 50 arises in this cumulative frequency table. So 50 arises between the 40 and 80. So the frequency class is this. In this particular case, small l is the lower limit of median class, and the median lower limit is 20. Frequency of median class f, which is equals to 22. CF of preceding of median class, that is the CF, which is 18. In some time it is represented by CF, or in some cases it can be represented simply by the capital F. Now the class width, that is the H. What is this? Difference between lower limit and upper limit, which is 10. So the formula for getting median, which is equals to L plus H into n by 2 minus CF upon small f. So put all the data there. L is 20, H is 10, n by 2 is 50, CF is 18 and small f is 22. So 20 plus 10 into 32 upon 22. So calculate it, you will get the answer. So this is the problem based on the formula when the data is grouped data. So now moving on to the mode. So what is mode? The mode of a set of data values is the value that appears most often. For example, the mode of the sample 1, 3, 6, 6, 6, 6, 7, 7, 12, 12, 17 is 6. Why it is 6? By the mode, we can get the value of the number which appears most of the time. So in the given data, 6 appears 4 times, while as 7 appears 2 times, 12 appears 2 times, and 1, 3 and 17 appears only 1 time. So the frequency of 6 is 4, which is the greatest in this given data. That's why we say 6 is the mode of the given sample. So the mode is a way of expressing in a single number important information about a random variable or a population. The mode is not necessarily unique. If there is another number 7 which have the same frequency of as 6, then the mode of the given data is 6 and 7. Or we can take the another example 1, 1, 2, 4, 4. So the frequency of 1 and 4 is 2. So in this particular case, the mode is not unique. So the given data or this type of data is known as the bimodal. Or if a data has more than 2 modes, then we may describe as multimodal data. So how to calculate the mode? One is the discrete data. From the discrete data, we can get the mode by the inspection. The value which has the maximum frequency is the mode of the data. But in case of group data, when the frequency table is given, then mode can be calculated by this particular formula L plus H Fm minus F1 upon 2Fm minus F1 minus F2, where small l is the lower class boundary of the model class, H is the class width of model class, Fm is the frequency of the model class, F1 is the frequency of the class preceding model class, F2 is the frequency of the class succeeding of the model class. Also, if we know mean and median, then mode can be calculated with the help of mean and median by the formula mode equals to 3 median minus 2 mean. So advantage of mode, it is easy to understand and simple to calculate. It is not affected by extremely large or small values. It can be located just by inspection in ungrouped data and discrete frequency distribution. It can be useful for qualitative data. It can be computed in an open-end frequency table. It can be located graphically. What are the disadvantages? It is not well defined. It is not based on all the values. It is stable for large values, so it will not be well defined. If the data consists of a small number of values, it is not capable to further mathematical treatment. Sometimes the data has one or more than one mode, and sometimes the data has no mode at all. If the frequency of all the data is same, then we cannot tell any number as the mode. So in case of mode, we have to identify a data at which maximum number of frequencies given. So the maximum frequency from this data is 40. So this is the Fk, this is F minus 1, this is F1, and this is the lower and upper limits for the frequency class. And the formula to get the mode is mode equals to L plus Fk minus 1 upon 2Fk minus F minus 1 minus F1 into H. So put all the data there. Lower limit for the frequency class is 30 plus Fk is 40 minus 22 upon 2 into 40 minus 22 minus 20 into 10. So 30 plus 18 upon 80 minus 42 into 10, or 30 plus 18 into 10 upon 38. This is around 34 point something. So this is the mode for the given grouped data. And if the data is not grouped, then you can find the mode by getting the term which has the maximum frequency. Come to the comparison with mean and median. Unlike mean and median, the concept of mode also makes sense for nominal data, that is not consisting of numerical values in the case of mean, or even of ordered values in case of median. Mode will be the best measure of center tendency, as it is the only one appropriate to use when dealing with nominal data. For example, taking a sample of Korean family names, one might find that Kim occurs more often than any other name. Then Kim would be the mode of the sample. So hope you understand the entire concept of measures of central tendency. Thank you for watching my video.